Challenge problem by Josh Kim. Yay! A geologist has collected 102 different types of silicate minerals. The geologist has taken a photograph of each mineral and wants to make a display of the photographs. So let's figure out part A. How many rectangular arrangements of the photographs are possible? So part A is asking you to find the greatest number that can be arranged in a rectangle. So we have to find the greatest common factor. There are two ways to find out the greatest common factor. One, listing, and two is prime factorization. So for listing, it's basically listing out all the factors, and for prime factorization, it's just breaking the numbers into prime numbers. So let's start with listing. And if we list all the factors of 102, there would be 4 ways. But then when you're arranging, you could switch the numbers. So you can make 102 into a column and 1 into a row. So you have to multiply the way by 2, which would be 8. Now let's try with prime factorization. So from 102, you break it up into 6 and 17. And then you could break up 6 to 2 and 3. And since 17 is already a prime number, you keep it, making it 2 times 3 times 17. And if you combine two different numbers in different combinations, you could get all of the factors we got from listing. And since we already know 1 is a factor, since 1's a factor for every number, there are 4 ways, and then if you arrange it in the opposite, making it 8 ways. Therefore, there are 8 different ways. The geologist wants no more than 15 photographs in any row or column. How many rectangular arrangements satisfying these requirements are possible? Part B is telling us that we cannot have more than 15 photos in any row or column. So let's first list all 8 ways to arrange the photos. The first 4 columns are less than 15, but the rows are greater than 15. And the last 4 columns are greater than 15, although the rows are less than 15. The final answer for part B. Therefore, none of the arrangements satisfies the requirement. Part C. The geologist decreases the number of photographs in the display to 96. How many rectangular arrangements with no more than 15 photographs in any row or column are now possible? So just like part A, there are 2 different ways to solve this problem. The 2 ways are listing and prime factorization. So let's again start with listing. So there are 6 different ways, but like before, if you can change the order so that the rows and columns would be different. So that would make it 12 ways. But out of the 12 ways, only 2 arrangements satisfies the requirement, 8 times 12 and 12 times 8. This is because the row 8 and 12 is less than 15, and the column 8 and 12 is less than 15. So, it satisfies the requirement. The next way is prime factorization. When you have broken down the number, it will be 2 times 3 times 17. And then you multiply in any combination of the 2 numbers out of the 3. Then, it will show all the factors, and you can arrange it the opposite way. So you multiply 2 by how many ways there are, which is 6. So after you multiply 2, it is 12. Like the answer we found from listing, there are only 2 ways that satisfies the requirement, 8 times 12 and 12 times 8. The last final answer. Therefore, 8 times 12 and 12 times 8 arrangements satisfies the requirement. Thanks for watching! Hooray! Yay!